Greg Perkins back, ready to do the Chapter 6 overview. So we're going to be using Table A2 quite a bit. Table A2 looks like this. It either came with your textbook, or if you look on the Math13 website, then near the top and somewhere else towards the middle, you'll see a link that says Table A2, and it'll take you to that. Or, of course, you could just Google it. So, by the way, if you do Google it, you don't necessarily say Table A2, but you would look for a z-score distribution. Okay, now let's get to work. So we've got a situation without a story, just that the mean is 50, the standard deviation is 4.2, and we're going to be using the normal distribution z-scores. So if it's a normal distribution, then the graph is going to look like this, with the mean of 50 in the middle. And I would suggest that you draw these graphs so that you can picture what's going on. It also helps for the next chapter to understand some of that. And now it's asking that what happens if a score is over 55. So right here would be x, an individual score of 55, and then over means to the right. So we're really looking for what's this shaded area. So if underneath the whole graph is 100%, then what percent is shaded? So the next thing to do is find the z-score. So that formula goes, you take the score minus the mean divided by the standard deviation. And this is going to be one of the rare cases, actually it's the only case, where we're going to round to 2 decimal places. So in the parentheses around 55 minus 50 is divided by 4.2. So that one actually is already rounded to 2 decimal places, 1.19. Now, table A2. So the way that this table works is, first of all, there is a positive z-score and a negative z-score chart, so make sure you've got the positive one. And then the next thing is you look up the z-score this way. So we had a z-score of 1.19. So here's the 1.1 on the left side. Then the last decimal place, or the second decimal place, is going to be up on the top. So this part, trying to get the whole thing on the screen, this part is saying that it's 1.1, and this part is saying that it ends in a 9. So then when you find out where these two intersect, it's going to be right here at 0.8830, or in other words, 88.30%. Now, if you look at the picture, this is saying that the left side is 8830. So that means I've got that this side is 8830. That means that this side is 1 minus 0.8830. So 1 representing 100% minus 0.8830 is 0.117, or 11.7%. So it would not be considered unusual to have a score over 55 because it's not lower than 5%, it's 11.7%. Next, the second one is going to be very similar, except it's between two numbers. So the beginning part is the same. Draw the bell-shaped curve. You put the mean equal to 50 in the middle. A 48 would be over here, x equals 48. And a 57 would be over here. And then we're being asked for the area between. So that's this shaded area. Don't you love my artwork? I do. Then we get to do the z-score twice. So the z-score for this one is going to look like 48 minus 50 divided by 4.8. So 48 minus 50 divided by 4.8 And we need to round that to 2 decimals, so we're going to have to go with negative 0.42. And then we need to do the z-score for this one. So it's going to be 57 minus 50 divided by 4.8. And that, once we round it, is going to be 1.46. Now it's time for us to look up these two values in table A2. So I'll look up the 1.46 on this positive chart. So it's going to go like this. 1.4 is here, then the last decimal place is 6. So if you go down this column and across this row, they meet right here at 92.79. But what that means is, if you went from this line all the way to the left forever, then that's going to be 0.9279. Okay, then we're going to have to look up the negative 0.42, which means I need to get the other chart. Here it is. The one that says the negative z-scores. So then look up a negative 0.42. So here it is negative 0.4, and then 2 would be this column. So those two meet at 33.72. 33.72. And this is telling you it's to the left of that, that's 33.72. So that would mean that if you go from this line to the left, that's going to be 0.3372. So this one covers our region, plus it keeps going to the left. And then this one takes care of this left part. So if we just subtract the two answers, then that's going to be the area in between. So 0.9279, subtract a 33.72, 0.9279 minus 0.3372, and the answer is 0.591, or you could write it as 59.1%. Okay, on to the next one. So now we have groups of 8. So there's 8 scores, and we want to know what's the chances that the average for those 8 is under 56. So this, having 8 scores instead of just 1, adds only one small thing to the problem. So we start off the same, bell-shaped curve. The mean goes in the middle. 56 would be over here, but now instead of being x, it's not just one score, but it's an average of 8 scores. And then under 56 means that the shading goes to the left. So then we do the z formula. So you take the score of 56 minus the mean of 50, divided by the standard deviation, which is 4.2. And here is the only thing that's different when you have a group of 8. According to the central limit theorem, what you do is take the standard deviation and you divide by the square root of 8. So, when I type this in the calculator, I need to put parentheses around the 56 minus 50, and I'm going to need to put parentheses around these two, so that the calculator understands this is the numerator and this is the denominator. So here goes. 56 minus 50 has its parentheses, divided by, then parentheses for 4.2 divided by the square root of 8. There we go, everything's in its parentheses. And that turns out to be a 4.04. Now that's the z-score, so we then go back to the positive table A2, and then you try to look up a 4.04. And this says, if you have any z-score that's 3.5 or up, then use 0.9999. And that's going to be for the left side, will be 0.9999. And it just so happens that ours is also the left side, and so that's going to be the answer, that it is 0.9999, or 99.99%. So just keep in mind when using table A2, if it's more than one score, or it's the average of n scores, the only difference is, right here, you take the standard deviation and divide by the square root of n. Central limit theorem. Okay, just on to page 2. This one is straightforward. Find the probability that a score is under 40. So we could work through this one pretty easily. The mean is equal to 50. Then 40 is to the left of that. And it's not saying a bunch of scores, but it's just saying a score, so it's going to be x equals a 40. And then under means to the left. So it's going to be this shaded area that we're looking for. So once again, do the z-score. This time it's just the regular z-score, so it goes the score of 40 minus the mean of 50 divided by the standard deviation of 4.2. So the score of 40 minus the mean of 50 divided, hey, what's that extra answer doing in there? Okay, we've got it now. 40 minus 50 parentheses, and then divided by 4.2. So that is going to be negative 2.38. Negative 2.38. And then we need the negative z-scores. So negative 2.38. So right here is negative 2.3. And then 8 is going to be over here. So if you follow down to where those two meet, it's at 0.0087. Keep in mind that that's for the left side, and that's what we have, so that's going to be the answer. Except I just forgot what it was. 0.00, that's right here. 0.0087. 0.0087. 87, that was my first year of college. Good old Fresno State. Okay, then for the other type of problem, this is where we use the table backwards. Because notice with all of these other problems, you're given a score, you use this, you use the chart, you end up with a percentage. 0.87% for that one. Now work backwards. You're given a percentage, so that would be, here's the graph, the mean equals 50 goes in the middle, and then to be in the top 4%. So the top 4% would be this. So this shaded area is 4%. And if it said the lower 4%, then I would put it down here on the left side. Top, that's going to be over here. The next thing is, there must be a z-score for that. So we have to find the z-score that goes with that. Well, we use the table, the positive z-score. Since this is on the right, the z-score would be positive. When they're on the left, the z-scores are negative. When they're on the right, z-scores are positive. So what we've got to do is use the table, the positive z-score table, and we need to know what this side is. Well, this side, the right side is 4%. That means that this side is 96% for that whole blank side. Then what you do is just plop the table down and start looking through it for whatever is closest to 96%. And I think I've found it. right here. Now you use the table backwards. You go to the left and find out the z-score started off with a 1.7, and then you go up and it ended with a 5. So that means it's 1.75. So then put that over here, z equals 1.75. Now that means that somebody did this formula right here, and for their answer they got 1.75. So in other words, somebody did the z formula, so they did the score minus the mean divided by the standard deviation, and when they did that they got the answer 1.75. And then we just have two steps of algebra. One would be multiply both sides by 4.2. And then just add 50 to both sides. So then that will be 50 plus 1.75 times 4.2. Or in other words, it's saying take the average of 50 and go 1 3/4 standard deviations to the right. And the score is 57.35. So whatever this situation was, that's the score you would need, a little bit over average, or a decent amount over average, in order to be in the top 4%. And then one more. So here is I'll put quotes around it when I say fact. I found it on the internet this morning in some newspaper survey. 77% of Americans claim Christianity as their religion. Suppose that a survey of 250,000 was taken. Find the probability at least 193 of them. So this is a binomial situation, but the n is huge. You may remember from the previous chapter when we did the binomial, we would use this distribution right here. So this would be the binomial formula. And then you have to put the n. And if you put 250,000 in the calculator, it most likely is going to say error, my brain is too small for 250,000. So we need another way. So we've got the p is equal to 0.77. Then we could find the q, so that would be those that say something other than Christianity. So that's going to be 1 minus the 0.77. So that equals 0.23. Okay. Next we have the sample size, n, is 250,000. And then we could use the formula that the mean is equal to n times p. So 250,000 times 0.77. 250,000 times 0.77. So in other words, on average, we would expect 192,500 of those people to claim Christianity as their religion. 192,500. Then we could also do the formula for standard deviation, which is the square root of n times p times q. Square root of 250,000 times the 0.77 times the 0.23. So let's see, the square root of 250,000 times 0.77 times 0.23, and the standard deviation is 210.416. So if you notice in this problem, what we needed was a bell-shaped curve. We needed a score, the mean and the standard deviation, and then we could use the z-score in table A2. Well, the same thing is true here. There's this theorem that says if n times p, which is this, is bigger than 5, and the n times the q is also bigger than or equal to 5, then the binomial situation, which this is what this is, could be approximated by a bell-shaped curve. So we would say, all right, here is the bell-shaped curve. I found the mean to be 192,500. Then find the probability that at least 193,000 people claim Christianity as their religion. So somewhere out here is that 193,000 or 193,000. Well, the person that is the 193,000th. And the thing is, this is a discrete value. This is one person. So that means that there's actually a bar that represents their probability of being a Christian. And we have to, it says at least, so that means it does equal that or it's bigger than. So that means that when we shade, we don't shade from the 193,000 because we have to include this person's bar. So we have to include them as well as all the numbers that are bigger. So that means that the shading didn't start at 193,000, it started just before that. Now right here is the previous person, which was 192,999. And then they have their own bar representing their probability. And so this line right here, which is called the continuity correction, is halfway between those two people. That means it's at 192,999.5. The continuity correction, that's called. So that's what we use for the z-score. So it's going to be z is equal to the 192,999.5 minus the mean of 192,500 divided by the standard deviation 210.416 that we got over here on the left. That is definitely calculator time. So let's see, 192,999.5 minus 192,500 parenthesis divided by 210.416. So that turns out to be a z equals 2.37, rounding to 2 decimal places. All right, we're almost done. Here we go. Z equals 2.3. So 2.3 is right here. And then 7 would be this column. And then those two intersect right here at 9911. And that means that the left side equals 9911. So that means that this side is going to be 1 minus that. 1 minus 0.9911. So 0.009, or just less than 1%, 0.9%. All right, that's it. We're done with chapter 6.